So this will be the next video in the observational studies versus designed experiment lesson. And in the first video, we talked about the difference between observational study and designed experiment. And we talked about different types of designed experiments. So in this video, we'll be doing more examples that should give us a little bit better idea about these different types of designed experiments. And then at the end, we'll talk about different types of observational studies. So let's start with this question. Determine whether the following descriptions correspond to an observational study, a controlled experiment, or a double-blind experiment. A new study examines the effect of regular exercise on child obesity by taking a survey of 500 children on their weight and exercise habits. This is an observational study because we simply took a survey of the children and we didn't attempt to influence their exercise habits or their weight. We just asked what it is. A doctor gives half of his or her patients in a study a treatment and the other half a placebo, but the patients do not know which they received. We'll call this one controlled experiment. It's controlled because there's a control group. Some patients are receiving the treatment and some are not. And the patients don't know which treatment they're getting, but the doctor knows because he's giving it to them. So it's not double-blind. In order to be double-blind, we would have to say that the doctor also doesn't know which treatment. A group of 500 adult males entered a study in which half would be fed a high-fiber diet while the other half would be fed a minimal fiber diet in order to determine the effect of fiber on cholesterol. So again, we have a controlled experiment. It's not an observational study because we are attempting to influence the outcomes. We didn't just ask a question and collect information. We are attempting to influence the outcomes by feeding either high fiber or minimal fiber, but it's not double blind. Okay, another example. The Nurses Health Study has interviewed a sample of more than 100,000 female registered nurses every 2 years since 1976. The study finds that light to moderate drinkers had a significantly lower risk of death than either non-drinkers or heavy drinkers. So we have that they're interviewing a sample and asking them, it appears they're asking them about how much they drink and about their health. So is this an experiment or an observational study, or do we need more information to know? This should be an observational study because we are just taking a survey and we're not attempting to influence the outcome of the survey. Another example, what electrical changes occur in muscles as they get tired? Student subjects hold their arms above their shoulders until they have to drop them. Meanwhile, the electrical activity in their arm muscles is measured. So, because it says student subjects hold their arms, it seems like all of the students hold their arms. We've got some group of students, and all of them are doing one action, and then we're seeing what happens. So is this an experiment with no control group, an observational study, or a randomized comparative experiment? It's not an observational study because we are attempting to influence the outcomes by having the students hold their arms above their shoulders. But it's not a comparative experiment either because we don't have some students holding their arms, some students not holding their arms. So it's an experiment with no control group. The control group would have been if we had some students who were just standing still and not holding their arms in any particular way. So this is an experiment because we're attempting to influence the outcome, but it is an experiment with no control group. What about a marketing class designs 2 videos advertising an expensive Mercedes sports car? They test the videos by asking fellow students to view both in random order and say which makes them more likely to buy the car. So we have 2 videos. They test the videos by asking fellow students to view both in random order and say which makes them more likely. The question says, Mercedes should be reluctant to agree that the video favored in this study will sell more cars. Why? A, results from the students may not generalize to the older and richer consumers who might buy a Mercedes. B, this is an observational study, not an experiment. C, The study used matched pairs design instead of a completely randomized design, or D, none of the above. Well, I think A is making a very good point here. Your typical Mercedes buyer is not a student, although perhaps a student somewhere has bought a Mercedes. Most of them can't, most of us can't. We might expect that the Mercedes buyer would typically be older and perhaps more affluent. So I don't think it's likely that just because students like the video and they want to buy the car, that the Mercedes customers will also feel the same way. It's not an observational study because clearly we have shown the videos, we're trying to influence their outcomes, and I don't think matched pairs design instead of completely randomized design is quite the right reason. So we'll go with A. And these are the things that you want to consider when doing this type of study or experiment. Example, 100 volunteers who suffer from severe depression are available for a study. So I'm going to highlight the fact that we have volunteers. 50 are selected at random and are given a new drug that is thought to be particularly effective in treating severe depression. The other 50 are given an existing drug for treating severe depression. A psychiatrist evaluates the symptoms of all volunteers after 4 weeks in order to determine if there's been a substantial improvement in the severity of the depression. The study would be double-blind if neither drug had any identifying marks on it, all volunteers were not allowed to see the psychiatrist, nor the psychiatrist allowed to see the volunteers. Neither the volunteers nor the psychiatrist knew which treatment any person had received. What we've talked about in a double-blind experiment, we definitely have to have C. Neither the volunteers nor the psychiatrist should know which treatment they are receiving. That is exactly why we would call it double-blind. So C is definitely true. Let's look at A and B. Neither drug had any identifying marks on it. Well, it seems like we should make sure that the drugs cannot be identified, because if they could, then the volunteers or the psychiatrist might know who'd been taking what. So we're going to need A. And B, all volunteers are not allowed to see the psychiatrist, nor the psychiatrist allowed to see the volunteers. That seems like that should be a good thing as well, so I'm going to go ahead and say all of the above. If we want to call it double blind, then we need both parties to be anonymous to the other party and to not know which group they fit into. The explanatory variable in the study is the use of randomization and the fact that it was comparative, the use of a psychiatrist to evaluate the severity of the depression, which treatment the volunteers receive, or the extent to which depression was reduced. So when we're talking about explanatory variables, we're talking about potential causes or treatments, we will sometimes say. So it looks like to me the new drug and the existing drug, those are the two options for treatments. So those are going to be our explanatory variables. And then the response variable is how much their depression is reduced, if at all. That's what we're trying to measure as the outcome. Suppose that the volunteers were first divided into men and women, and then half of the men were randomly assigned to the new drug, and half of the women assigned to the new drug. The remaining volunteers received the other drug. This would be an example of, this should be a block design. So what were our choices? Replication. Well, we didn't repeat the experiment more than once, so it's not replication. Matched pairs designed. That would be if I gave first the men the new drug and the women the old drug, and then later I switched and I gave the men the old drug and the women the new drug, something like that, so that everybody gets the new drug and the old drug, but we can compare the results across these two categories. Well, we haven't done that because it says half of the men are given the new drug, half are assigned the other drug, it's random, and then we don't go back and do another round where everybody receives the other drug. So it's not matched pairs. Option C is confounding. Option C is this would be an example of confounding because the effects of gender will be mixed up with the effects of the drugs. That is an interesting thing to think about, but as far as we know, we have no information to suggest that gender has any effect whatsoever on level of depression or the response to the drug. So we wouldn't choose C, we would choose D, a block design, because we're splitting them up as men and women. Those are the blocks. And then within each block, we're randomly assigning some will get the drug and some will not. Example, decide whether observation or experiment. Researchers want to know if there's a link between proximity to high-tension wires and the rate of leukemia in children. To conduct the study, researchers compared the rate of leukemia for children who lived within half mile of high-tension wires to the rate of leukemia for children who did not live within half mile of high-tension wires. So is it an observational study or a controlled experiment? Well, it doesn't appear that the researchers have attempted to influence the outcomes in any way. So I'll say this is an observational study because they didn't ask the children to live within half mile or not within half mile of the wires. And they didn't put new wires in the neighborhoods where the children lived to observe the effect. They simply asked the children who were already living where they were living for information about their health. Okay, 2, rats with cancer are divided into 2 groups. One group receives 5 milligrams of a medication that is thought to fight cancer, and the other receives 10 milligrams. After 2 years, the spread of the cancer is measured. This is definitely an experiment because we are attempting to influence the outcomes. That is to say, we're giving treatments to see how much of what treatment works. So it's an experiment. 7th grade students are randomly divided into 2 groups. One group is taught math using traditional techniques. The other is taught math using a reform method. After 1 year, each group is given an achievement test. This is also an experiment. Because again, we have treated the different groups different ways. Some of them taught math one way, some taught a different way, and we see the outcomes. What about a poll is conducted in which 500 people are asked whom they plan to vote for in the upcoming election? This should be an observational study. As long as in the surveying process, no one is attempting to influence the responses. If you're simply asking people whom they plan to vote for, then you're just observing the response. Similarly, in a survey of 400 people asking, do you prefer Coke or Pepsi, we would say this is an observational study. And again, as long as no one is attempting to influence your choice of Coke or Pepsi. They're just asking you for your preference, and you're simply stating your preference, so it's an observational study. Okay, this is an interesting example. A study of human development showed 2 types of movies to a group of children. So I'm going to highlight there are 2 movies, 1 group of children. Crackers were available in a bowl, and the investigators compared the number of crackers eaten by the children while watching the different kinds of movies. So the number of crackers eaten is the thing that we're measuring. One kind of movie was shown at 8 a.m. The other kind of movie at 11 a.m. It turns out that during the movie shown at 11 a.m., more crackers were eaten than during the movie shown at 8 a.m. The investigators have concluded that the different types of movies had an effect on appetite. Question A, a lurking variable in this experiment is what? The bowls, the different kinds of movies, the time the movie was shown, the number of crackers eaten. So the different kinds of movies shouldn't be a lurking variable because that's in the experiment. They've accounted for that. The number of crackers eaten is what they're trying to measure. So we have the bowls, or the time that the movie was shown. I think a better, more likely lurking variable might be the time that the movie is shown. Because what they found out is that at 11 o'clock, children are eating more crackers than at 8 a.m. So in this case, I would say it's more likely that the kids were just hungrier at 11 a.m. than that they preferred a certain type of bowl, although I suppose that could happen too. But the more likely lurking variable is the time. The response variable in the experiment is what? So the response variable is the outcome they're trying to measure. Is it the bowls, the number of crackers, the different kinds of movies, or the time that the movie is shown? And I think it should be the number of crackers. So they're trying to measure if the different type of movies have an effect on the number of crackers. So the response variable is the number of crackers. C, this is an example of a matched pairs design, a simple random sample, a block design, or none of the above. And so we have one group of children. They're shown at 8 a.m., one type of movie, and another movie at 11 a.m. So we have two different movies, and each child is getting to watch all of the movies. So this is what we'll call a matched pair design. If you had split the group of children up and said, some of you get to watch this movie and some of you get to watch that movie, we wouldn't call it a matched pairs design. But because all of the children first watch one movie and then next watch a second movie, this is called a matched pairs design. So now let's talk a little bit about types of observational studies. We've already talked about different types of experiments like double-blind experiment, block design, and so on. We also have major categories of observational studies: cross-sectional studies, case control studies, and cohort studies. So we're going to learn a little bit about each of them and the pros and cons. A cross-sectional study is an observational study that collects information about individuals at a specific point in time or over a very short period of time. For example, a researcher might want to assess the risk associated with smoking by looking at a group of people, determining how many of those people are smokers, and then comparing the rate of lung cancer of the smokers with the rate of lung cancer in the non-smokers. So that would be a cross-sectional study because we're just looking at a group of people at a specific point in time. The pros to this, or the merits, would be that they're cheap and easy to do because you're just looking at it once. But the demerit are that they have limitations. For example, in the lung cancer study, individuals might develop cancer after the data is collected. So the data of just asking them at a certain period of time if they have lung cancer doesn't really give us the full picture about the relationship between smoking and cancer. Another type of observational study is a case-controlled study. These studies are retrospective, meaning that they require individuals to look back in time or require the researcher to look at existing records. In case-control studies, individuals who have a certain characteristic may be matched with those who do not. For example, we might match individuals who smoke with those who do not. When we say match, we mean that we would like the individuals in the study to be as similar as possible. And sometimes another word we use for similar is homogeneous. As similar as possible in terms of demographics and other variables that might affect the response variable. Once homogeneous groups are established, we would ask the individuals in each group how much they smoked over the past 25 years. Then the rate of lung cancer between the two groups would be compared. So a merit, an advantage of case-controlled studies is that they can be done relatively quickly and inexpensively. But a disadvantage is that it requires individuals to recall information from the past. It also requires the individuals to tell the truth. One other type of observational study is a cohort study. This is a very good type of study. A cohort study first identifies a group of individuals to participate in the study, and we call that the cohort. The cohort is then observed over a long period of time. During this period, characteristics about the individuals are recorded, and some individuals will be exposed to certain factors, not intentionally, because remember, this is an observational study, so we're not intentionally exposing them. But over time, some will be exposed to certain factors and others won't. So at the end of the study, the value of the responses are recorded for each individual, and then we might compare based on what factors they encountered. Typically, cohort studies require many individuals to participate over long periods of time. So the advantage is that this is the most powerful observational study because the data is collected over time. So they're prospective. On the other hand, the downside to this is that individuals might drop out of the study. So you might be collecting information about them at first, but then they can't complete the study for some reason or another. And they are likely very expensive to perform. So this could lead to misleading results if you're losing people during the course of the study. And just an interesting note here is that one of the largest cohort studies ever conducted is the Framingham Heart Study. In the study, more than 10,000 individuals have been monitored since 1948. And the study continues to this day, with the grandchildren of the original participants taking part in the study. This cohort study is responsible for many of the breakthroughs in understanding heart disease, but its cost is in excess of $10 million. So if you have a little time after this lesson and you want to go online and Google this study, it's fascinating what they've done. And as it says, it's been very enlightening and it's helped researchers learn a lot about heart disease, but it hasn't come without a cost. So this is the end of this lecture, and as we said in the beginning, we had some objectives to distinguish between observational study and experiment, and to explain the various types of observational studies and the various types of experiments. At least the basic types that we discussed here. So you'll ask yourself if you are now able to complete these objectives, and if not, there are 2 videos. Go back and watch the corresponding video.